Welcome to our first video where we're going to get started talking about writing FRC code to get our robot up and running. So before we begin, just a few logistical and setup things. So if this screen in front of you looks unfamiliar and you have no idea what you're looking at, check out our previous video where we talk about installing everything that you need to get WPI lib and all the code stuff necessary in order to get started. And second, we will not be covering Java fundamentals in this tutorial series. So there are a few links in the description of this video where you can check out some documentation we've written on some Java basics that are relevant to FRC. So if you are completely new to programming and you'd like to get started on learning some Java foundations, then you can check out those links in the description below. So before we even get started with the whole coding process, we need to set up a project in Visual Studio Code. Now, in Visual Studio Code, you'll see this little red W icon right here, and that's where we'll access all the FRC Java-specific stuff that we need to do and any robot-specific stuff that we need to do, such as deploying code, simulating code, etc., which we'll talk more about as we progress through this video series. But for now, in order to create a new project, what you're going to do is click on this red icon and just type in new. And then you'll see right here, WPI create new project. Go ahead and click on that. And then you'll be brought to this page. So this is the project creator. And the first thing you want to do is select a project type. That's right here. So for us, and what we tend to use throughout the season as a team is template. We're going to be coding in Java. And then we're going to be doing a command robot. So that's the first one right here. Next thing you want to do is select a project folder. So this is where Visual Studio Code will save all your code. So for me, that's just going to be my desktop. Next, you want to give yourself a project name. I'm just going to call my thing video tutorial. Video tutorial. And you can call it whatever you want. You call it first project, whatever you feel like. And the next thing you want to do is enter your team number. And for us, that's 1923. And then once you've got all this, go ahead and hit generate project. And yes, we'll open it. And if you ever see this pop up, you can go ahead and hit trust all the authors. All right, so give it a second it's going to execute this task called build. We're going to talk more about what that means later on, but for now, just let it completely build. You'll see this or this wheel right here. You can say opening Java projects. Give it a second just to completely build, and it should say build successful in green once everything is complete. So we're going to give that a second. You can see right here where it's just running that whole process of building code. And building code is just essentially making sure that there are no errors within your code, making sure that everything can compile correctly, and making sure that there is, nothing syntactically wrong with your code that could prevent it from running on the robot in the first place. So that's what build is doing right now. And every time you deploy or send code to the RoboRio, it's going to run a build process just to make sure that code can compile. And one other thing to keep in mind is that anytime you open a fresh project and you build it for the first time, it's going to take a very long time. Like it says right here, any builds that are subsequently run will be significantly faster. So here it said 1 minute 4 seconds. Usually takes around 20 to 30 seconds to build code. But now that we've got that done, it's time to get into the fun stuff and start learning how to write code to spin a motor. So the bulk of FRC code and where it's primarily run is over here. So if you click on source, you hit Java, and you go to robot.java, double click that, you'll get this file right here. Now this is where the majority of our code will be written, at least for the first few videos that we'll be going over. Eventually we're going to be moving on to something called robot container, which you see right here, but for now we're going to stick with robot. And so what this code class does is it essentially is where you can tell the robot to do things, right? So we've got a few different methods right here. This one's robot init, robot periodic, and there's disabled init, disabled periodic. There's autonomous init, autonomous periodic, tally up init, and tally up periodic. And we're not going to worry about tests for now. So in all these different methods, you can specify what you want your robot to be doing. So in robot init, you can tell the robot to do something the very first time it boots up. And in disabled init, the second the robot enters its disabled state, which we'll talk more about once we go over the driver station towards the end of this video, the second it enters disabled, what do you want the robot to do? Then we have autonomous init, which is the second the robot enters its autonomous mode, what do you want it to do? What motors do you want it to spin? Do you want the robot to do something, etc.? And then in teleop init, the moment that teleop starts, what do you need your robot to do? And then with each init loop, you're going to see some periodic loops as well. Now within the periodic loop, that's what the robot will do repeatedly. So you'll notice that within this comment right here, this function is called every 20 milliseconds. So the periodic loop is run every 20 milliseconds. Like it's constantly updated. It's a continuous loop. So whatever you put in periodic, it's always going to happen unless you disable your robot and stop it. So you'll see as we progress throughout the video series what the real difference between a periodic loop versus an initialization loop is. But for now, everything that we're going to be doing is in teleop periodic. So in order to make our motors and actually write code for them in the first place, the first thing that we need to do is import a library that allows us to interface with our motors. So WPILib as is does have a few motor classes in general, but if we want to work with Falcons, which is what our team primarily uses, then we're going to need to download an external library in order to make our code interface with the motors that Cross the Road Electronics, the manufacturer of the Falcon, who they write code for it, provides for us. So what we're going to do is if you head over to Chrome or your web browser of choice, and if you look up Phoenix Vendor Library Install and click this link right here by CTRE, and if you scroll down, you're going to see a link in this green box, and go ahead and copy that link. And now head back to Visual Studio Code. And what you're going to do is click this red WPILib icon once again, and then you're going to type the word manage. And then here you'll see manage vendor libraries. So this is where we can add our external libraries that allows us to write code for our Falcons. So go ahead and click on that. And then we're going to install a new library online. Now, there are a few different versions in terms of installation. So the first one's online, the second one's offline. And the difference there is that online, it can pull the library from a JSON file as long as you have an internet connection, whereas offline is you have to manually install things. Online is generally preferred since it's the easiest way to go about it, and anytime that you work with your code, you might sometimes need to connect to Wi-Fi and build your code so that any updates that need to happen can happen, because another thing that happens when your robot builds, when your robot code builds, is that there are updates happening. So if there's an update to WPILib, if there's an update to your library, it'll automatically update as you build your code. So as long as you have a Wi-Fi connection, you're fine, and this has worked for us in the past, so we like to install new libraries online. So go ahead and click on that, and just paste the link that we copied, and then hit enter. And you can see here it's recommended to run a build to make sure everything's installed correctly, so we're going to go ahead and hit yes for that, and our code is going to build. Cool. Now that our code is built, you'll notice that we have this vendor deps folder, and if I click on it, you'll see we have phoenix.json, which is exactly what you're looking for. So make sure you've got this, and once you have it, you know you're good to go. So now comes the fun part about actually making a motor in code and making it spin. So the way we declare motors in FRC coding is pretty much the exact same way that you would declare a normal object in Java. So remember that in the structure of a Java class, all the attributes of a class are private. So that's exactly what we're going to start with. We're going to make our object, our motor object, private. And the name of the object, rather, is TalentFX. And you can see autocorrect is already helping me out here by saying, oh, do you want to make a TalentFX object? That's exactly what we want to do. So TalentFX, and then we can call it motor. And then we're just going to make a new TalentFX, and then our device number. So this allows us to create a talent effects object, which is a motor object. And this argument inside the constructor for the talent effect object is the ID of the motor. Now, the ID of a motor is something that you can specify in a tool called Phoenix Tuner. So I'm going to go ahead and open that. Give it a second here. And if you have a connection to your robot, what you can do is click on CAN devices right here, and you should be able to see all of your motors in this list right here. And with each motor, you can click on them and you can notice I can change the name of the motor so I can easily identify it within Phoenix Tuner, and I can also change the ID. So one thing that you want to do when you assign IDs to different motors is click on each motor and blink it and make sure it's the motor that you're actually wanting to change the ID of. And once you've verified that, you can change the ID to whatever you'd like. For now, I'm going to leave my motor ID here inside code as 1, just to make it easier. And we'll talk more about Phoenix Tuner and how to work out some of the kinks of it in a later video. But for now, if you want to set up just one motor connected to a RoboRio, all you'd have to do is just click on the motor and change the ID to 1. And that'll interface with our code as needed. So I'm going to go ahead and close this. So now that we've got our motor constructed, we're going to head over to teleup periodic. And the most basic way of making our motor spin is to say motor.set. Motor.set. And then you'll notice that inside Visual Studio Code, it takes in 2 different arguments. So one is a control mode, and one is a demand, meaning the number that is associated with your control mode. So we'll talk about that in a second. So the most basic way, like I was alluding to earlier, of controlling a motor is running it for a certain percent output, meaning I want to run at 10% of its output capacity. So in order to specify that, our control mode, which you can type right here, is going to be .percent output. And now I can type in a double range from -1 to 1 and specify the output at which I want to output my motor at. So I can do something like 50%, which would be represented by 0.5. I can do something like 25%, or I can go the other way and specify -25%. It's whatever I want. Now, for safe values, to make sure our motors don't go crazy, we're going to stick with 0.15 for now. And this line right here will allow your motor to spin at a percent output of 15%. Now, there are other different control modes that we're going to be talking about that are a little bit more advanced that we'll use later on. But for now, percent output is going to be the most basic way for us to actuate our motor. So now we want to actually test this, right? So what you'll do when you have connection to your robot, either by plugging it in or by connecting through the radio, is head over to driver station. Give that a second to open up. And you'll see I've got driver station right here. And I just want to talk through a few things on driver station just so that we're all aware. Give shuffleboard this guy a second to close. Cool. All right, so over here is some of your status about your robot and on your computer, about your computer as well. So you can see how much your PC charges, how much your CPU is being utilized by driver station right now. And you can also set up which driver station you're on, which is relevant depending on what you're testing and what you want to see. And here you've got some of your robot stats. So if I was connected to a robot, I could see my robot's voltage. I can determine if I have communications. I can see if robot code has been successfully loaded onto the RoboRio. And I can see what joysticks I have connected. Over here are the different modes that I can enable my robot in. We're mainly concerned with teleup and autonomous right now. So teleup, again, is when you can control everything with the controller, which we're going to talk about soon. And then autonomous, of course, is that 15-second period where everything happens with the robot autonomously. So because we're only running a motor in teleup periodic, the motor will only spin inside teleup. So that's the mode that you're going to want to run your robot in. Now there are some other menus inside the driver station that I'd like to take a second to go over. So over here you've got your diagnostics, and this is mainly showing you, all right, do we have a connection to the robot radio? Do you have a connection to the robot? This also gives you the option to see your driver station versions when you're connected to the robot. You also have the ability to reboot your RoboRio and restart robot code as necessary. Over here in settings, these are just some general things. This is where you can set your team number. This is where you can set up your dashboard, which we're going to talk about in a future video. And this is just for the practice mode, which allows you to mimic a real match by setting timings for autonomous, the delay between autonomous and the teleoperated period, how long teleop is and how long endgame is, as that could change depending on the game that we're playing. Over here in the USB menu, you can see all the joysticks that are connected. Obviously, I don't have anything connected right now, but if you were to have something connected, then it would highlight green, and you can actually click on it and interface, which I'll show you in a future video. And next over here is just some utilization metrics. You can see how much of your canvas is being utilized and all that fun stuff. So what you're going to want to do before you even run anything on your robot is deploy your code. So over here, again, you're going to open the WPILib command palette and hit enter, type in rather deploy, and you'll see this option right here. Now I'm going to click on it, and it's not going to work obviously because I don't have a robot connected, but we're going to let it run through that whole process. So it's running through its build right now. It's compiling the code. Give it some time here, and obviously it's not going to work because no robot is connected, so my build failed. But it should work all right for you so long as you're connected to your robot and you don't have any major errors in your code. Once you've got your code deployed, you're going to hit this enable button, and hopefully you should see your motor spin. So you can go ahead and test out what the different percent output values do, see your motor spin in different directions, etc., and have fun with that. And that about wraps it for our first video here, and hopefully I'll catch you in our next video.